Hi, I'm Ryan from Amber Valley High School, and this is my second milestone in my gesture controlled robot project. Last time I was here, I had the basis of the car made. I had all the motors hooked up to the H-bridge and the Arduino Uno, and I hard-coded a move forward method. Today, however, I worked on the controller for the car um, using Bluetooth modules to send and receive data, and I also put a switch so I don't have to unplug and reflug the battery every time I turn on and off the car. So I'll start with what I did for the controller. It's on this solderless breadboard here. It has an Arduino Nano in the middle. On this side, it has the MPU 6050 access accelerometer, and here is the HC05 Bluetooth module. This the access accelerometer takes 5 volts, and the HC05 Bluetooth module takes 3.3 volts. So they're connected to those ports on the Arduino Nano, and they're both connected to the same ground. And in turn, the Arduino Nano is being powered through my laptop. And then on the car, I have this Bluetooth module here, and I also have this switch, which I added to the battery. As everything was hooked up to the H-bridge, all I did was where the battery was plugged in, I added it one side to the ground, and I added it in the middle of the voltage going from the battery to the H-bridge. So it cuts the current whenever I flip the switch on or off. So it can access or can't access the battery's power. And lastly, the Bluetooth modules. Aside from having power and ground, which is VCC and GND, it also has also has RX and TX pins for receiving and transmitting data. And those are mapped right here on the Arduino Nano to ports 3 and 2, which I will show you in the software now. That's good for the screen. You can see it well. Okay, so first for the controller right here, the Arduino Nano, I just imported some libraries so I could use methods for the Bluetooth module as well as the Arduino specific control methods. In setup, I just set the baud rate and began the serial.bluetooth transmission. And then in the loop, I have two methods. One is read accelerometer, and another is determine gesture. In the read accelerometer method, we began transmission with the axis accelerometer, the MPU 6050, and then we just do some more declarations, and we defined the X, Y, and Z as 16-bit characters up here, and now we're setting them equal as our X, Y, and Z axes. So we use wire.read to initially set them, and then we map them from their initial range of 17,000 just from that to 0 to 180. So it's easier to use with the implementation of a car. It also makes more logical sense because in the sphere of this movement, it would really only need to be 180 degrees. And then I print those values here after setting them equal to the X, Y, and Z. And then in the determine gesture method, I have if and else if statements. So essentially the X, Y, and Z being recorded by the MPU 6050. Depending on those values, you can determine, you can even see right here, let me reset the serial monitor. You can see these values constantly changing. That's the axis, all axes that are being printed from this monitor. Depending on these axes, I can know if it's going forward or backwards, left or right, as such. And then I can use these if statements to determine what that gesture is. And then I write to the Bluetooth module what direction it is. I have used kind of like the symbols that I could for arrows, because currently I need to use a char for this. I thought the arrows would be the simplest way to do that. And then in the Arduino Uno code, I have everything from the basic setup of the car. I did initiate the TXD and RXD pins on this Bluetooth module, so it knows, the Arduino knows what's receiving, what's transmitting, and I called that in the Bluetooth.serial here, where I set it up. All of this is the same as before. I have my basic move forward method. I begin my serial and I set my baud rate to 9600. And then I have a stop as well as a move forward method. And then in my loop, I'm checking to see if the Bluetooth.serial is available. Essentially, the output from here, the signal, the TXD pin, and then I'm setting it equal to Z, and then I'm printing Z, so you'll be able to see in the terminal how it's working. And then depending on Z, I'm using a switching case function. So in the switch, it inputs Z, which is going to be, again, what you're reading from here, like this specific char, which is looking to be left, or it could be this char, which is pointing up. And then it will direct that to the appropriate move method for the car, depending on the statement that it receives. So I'll give a quick demo now. First, I'm going to switch on this through the battery because there's not enough voltage to power the motors if everything is just running off my laptop. So I need the battery to be connected fully. Let me get the serial monitor cleared. Okay, so the car will now move forward if I tilt forward, and then just here in the center it stops, right? And you can see it was printing that same thing to the terminal here. The values that it's receiving from here, it's printing. So it's printing forward stop, which is exactly what the car has done. This is my progress so far. For my third milestone, I look forward to getting all the directions to work. I look forward to maybe combining some of the directions. So you, like in a normal car, you can go forward but left and right at the same time, not just like forward stop, left stop, right stop. To try to make it easier to use, maybe more fun to use. And then I'm also aiming to, yeah, I'm also aiming to rewire some of this and make it more organized as well. And some of the challenges I faced when getting to this milestone was a lot with the Bluetooth. Let me switch this off so it doesn't move. There's a lot with the Bluetooth. There's a lot of specific methods and also AT commands you need to do in the serial monitor of Arduino IDE to get these two configured as master and slave. Slave is 0 and master is 1. And I had never configured Bluetooth modules before, so I found that a little difficult to learn. But I think I have a much better understanding of the basics of how to do it now. And there was also methods I had to use, like the mapping method for this. I never would have guessed how to use that. I had to read a lot of documentation and figure out exactly how I was supposed to implement those methods and also what they did. So I would say research and AT commands to pair these two Bluetooth modules were the hardest things about this milestone. Thank you.